Hello, my name is Marte. I was in charge of doing the map and the collision for the project. We got the tile pack from each eel, and it's basically this one. It has like a prison theme. These are the tiles, and these are the props. Basically, to make the map, what I use this application called Tile. And Tile is basically a map editor that you can create 2D game maps. Uh, Here you can see this is the map that I made. It's a 100 times 100, and each tile is 16. This application makes everything easier, and you can put layers on top of everything. And it's really easy to use. If you wanna make a map, you just gotta make a new map, and then you can choose how many the width and the height. I choose 100 times 100, each tile 16 by 16, and basically you can do whatever you want here. The idea that I have for the map is basically you start here and you have to go all the way up here. It's gonna be enemies everywhere. Then you have two sides to choose. The left side is kind of like a maze. The right side is kind of like you have traps everywhere. And you have to basically defeat all the enemies. Go down here. This is kind of like a boss area. And also the left side has like a boss area. You have to defeat these two, and then you go to the next one. After you defeat this one, you win the game here. Okay, now let's talk about the collision itself. So basically, I use the map as an image, and the walls. I use the collision system that we learned in class. It's the same code that our professor showed us. And so we're using this class that we learned in class to make the walls, where x, y is the position, wh is the size, and vx, vy is the velocity of the rectangle. And then we use, from here we use contain, which this method checks if a point mx and my is within the rectangle. Then we use overlaps, which it checks if another rectangle r overlaps with the rectangle. And then so basically how it works is if came from above, it's gonna get pushed back up. If came from below, it's gonna get pushed back down. If came from left, it's gonna get pushed back left. If came from the right, it's gonna get pushed back right. So basically how it works, came from left, it's gonna calculate the position on the right edge of the rectangle in the previous frame. If the position is less than the edge of the rectangle R, it means the rectangle came from left. Then it will be basically the same from the right. It's going to calculate the position on the left edge of the rectangle in the previous frame. If the position is greater than the right edge of the rectangle R, it means the rectangle came from the right. Then for the above, it's going to calculate the position of the bottom edge of the rectangle and the previous frame. And if the position is less than the top edge of the rectangle, it means rectangle came from above. We came from below, it's it's gonna calculate the position of the top edge of the rectangle in the previous frame. If the position is greater than the bottom edge of the rectangle, it means that the rectangle came from below. Then we have the pushback methods, so now with the pushback methods, it would be basically when the rectangle's right edge is positioned to the left of our left edge, it's gonna add the -1 to create a small gap to prevent further overlap. Then it's basically the same with the right edge. If the rectangle left edge is positioned to the right of ours right edge, it's gonna add the +1 to create a small gap. Then the pushback up front is gonna be when the rectangle bottom edge is positioned above ours top edge, the -1 is added to create a small gap, and the vertical velocity is set to 0 to stop downward movement here. Also the same with the pushback down, which the rectangle's top edge is positioned below ours bottom edge. Then the +1 is gonna create a small gap, and the velocity is gonna set to 0 to stop any upward movement. And so basically, in conclusion, when the game detects collision using the overlaps, then it checks the direction of the collision using the came from. Based on the direction, it adjusts the rectangle position using the pushback method. For example, if the rectangle overlaps with a wall and it came from the left, the pushback leg from method is called and adjust the position to the left of the wall. And it's gonna look like this. Let me show the collision. Oh, also these are all the rectangles. I know it may not be the best way to do it, but these are basically all the walls that are implemented in the game. These are the objects and everything on the ground. Let me draw them. Yeah, so these are all the walls that are in the game. As you can see, everything has a collision. Also, it was not that hard to pick all the coordinates, since if you use the tile app, you can see on the bottom left here, down here, you can see that it tells you the coordinates of everything. And because each tile is 16 pixels, then basically if you see here, you just gotta multiply each tile by 16 and then you got the coordinate. But because we have the map 3 times bigger, then you have to multiply the number that you get after multiplied by 16. You have to multiply times 3, and then that's your coordinate. So for example, if you wanna know what coordinate is this one, you gotta multiply 50 times 16, and then 16 times 3, and then you get your x coordinate. And basically that was all I did for the project. Thank you.